TF IDF. TF, this is responsible for term frequency, and IDF means inverse term frequency, sorry, inverse document frequency. Now let's see what is this two technique means about and what is its advantage from the back of our techniques that already we have learned in previous video. Okay, the back of war already we have learned in previous video that's actually applied to convert some text to a vector. We have already learned this concept, and there have concept also various new concept or learn, that is n-grams. What is its advantage, what is its disadvantage, we have learned it, and how to pre-process the data. That's kind of thing already we have learned. Now let's see what is this TF-IDF. So better if we take some examples, and through these examples if we discuss it, it will be better for us. So we have to review R1. R1 is the review combinations of these words W1, sorry, W1, W2, W3, W2, W5. Combinations of these, suppose let's combinations of these 5 words. So here combinations of the, suppose let's, and another text we have, sorry, another sentence we have R2, another review sentence. Suppose its word is W1, W3, W4, W5, W6, and W2. So here we have 6 words for this review, for these sentences, and here we have 5 words for these sentences. So we have seen how to convert this text, this review to the vector. We have seen it. Suppose it's the vector 1. If we use the back of our technique to convert these sentences to some review, this age dimensions is responsible for each word. So how much word there have 5 words, so its dimension will be 5, 1, 2, 3, 4, and 5. So just remove this one, not necessary. Okay, so its value will be what? Its past, yes, its dimension is how much? 1, 2, 3, 4, 5. How much dimensions they have? W1, W2. This cell is responsible for word W1. This cell is responsible for word W2. Similarly for rest ones. Okay, so W1 is occurred here, so it will be yes. W2 is how much time W2 occurs? 2 times. It will be 2. W3 yes. W3 no. W5 yes. Okay. Similarly, if we calculated the W2, sorry, vector 2 for this review 2, here how much word? 1, 2, 3, 4, 5, 6. How much distinct word they have? I think I have missed. Okay, how much distinct word? Here also from 6, 1 to 6. Okay, 1 to 6. So if you consider here also total how much unique words they have? 1, 2, 3, 4, 5, 6. Total 6 words. So it will be better if we consider in our text 6 means our vector dimension of the vector will be the number of unique words in our data corpus. So if we consider these R1 and R2 are now our data sets, so it will be now here R1 is not appear here. So the dimension, so the vector 2 will be for review text 2, it will be look like this: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So here the value will be W1 yes occurs, W2 yes occurs, W3 yes occurs, W4 yes occurs, W5, W6. But I think everything is repeated or not? No, here is not anything repeated. So this value will be like, so we have seen this technique already. We have seen this technique in back of word technique. We have already learned this thing, how to calculate this review text to a vector by simply using this thing. Now suppose let's take in this let's take we have such kind of n documents. It Rn. We have in our data sets we have such kind of n documents. Here capital N is the number of documents. Documents means such kind of review text, or you can call it is a number of reviews. Okay, means this is the size of the data corpuses. Okay, this capital N. Now what will be the definitions? So let's clear what is the term frequency. First try to understand the term frequency, then I am going to the inverse documents frequency. First try to understand the term frequency. What is this term frequency? So the term frequency definitions will be like this. Term frequency is equals to, suppose we have picked any word from any review. Suppose we have picked any word WI, and for any review, I have picked any review here. Suppose I picked up any review J. So this formula will be number of times in numerator. You will write number of times WI occurs. So first write it, then we will try to understand geometrically. Number of times WI occurs in the text or in the documents are J, divided by, in denominator it will be total number of words in this text or in this document. Total number of words. Total number of words in RJ. That's the simple definition. So you can think it is like a probability type of concept. So let's calculate it. Let's calculate it for some examples that I have taken here for review somewhere. Review 1. Let's take, I am calculating the W2 for review 1. So what will be the TF IDF value for the W2 word 2, for the text 1, for the sentences 1, or for the documents 1, as you call this thing. So for R1, first is what? In numerator, number of times WI occurs in RJ. So here number of times W2 occurs in the review text R1. How much time? 1, 2, only 2 times. So in numerator it will be 2. In denominator, total number of words in the review J, means total number of word in this review R1. How much word we have? 1, 2, 3, 4, 5. Total 5 words we have. So this thing will be TF for the word W2, and for the word W2, and for the text R1, it will be 2 by 5. So term frequency here it will be 5. So you can think this thing, you can treat this thing is like this way. So this is the how often does this WIs occurs in this in RJs. This is this meaning is in English meaning actually. If literally thinking this thing, TF, concept of TF, its literal meaning is how often does this or WI occurs in the review J. That's the meaning, Tarid. And it is not possible this TF value will be greater than 1 because maximum. So here, what will be the maximum value? Maximum value will be 1, means in a single sentence it's the number of times that occurs. So it's actually this, that how much words we have in a sentences. That's the meaning. So that value of the TF must be less than equals to 1. Okay, so the value of TF for a particular word wi and particular sentences or texts wj, it must be less than is equals to 1 and this must be equals to, because see, just see it here, the number of word, any word on this text, it cannot possible to occurs means 5 times. Here at most word number of words has 5. So there have no possibles any word occurs at means at most 5 times. Means here it is not possible anywhere for occurring 6 times. Means here maximum number of word is here 5. Okay, so there have the maximum chances for occurring each word is 5. Because of these three reasons, this maximum value will be 1 and minimum value will be 0. This is, so you can think like a 0, and already we have learned the concept of probability. It's think like a probability type, probabilistic type of concept. Probability type of concept. So the TF actually internally TF gives us how often does a word wi occurs in a particular text or particular documents. That's the main job that TF doing. Okay, now let's try to understand the what is IDF. IDF, what it means, inverse document frequency. What is it? Let's understand it. So same, let's take to an examples. We have this n documents R1. Means don't be confused. I am repeatedly use the sentence and documents. So both are the same kind of thing. So it depends on our problem to problem. Okay. So suppose it's a document. Each R1 is a single document, R2 is a single document, R3 is a single document, or you can see R1 is single sentences if you take the review example. Okay, as you. So suppose we have such number of documents, n documents we have, and these things are actually called the data corpus. Data corpus. Okay. Suppose later there have some where has some combinations of word for each sentence, so each sentences or each documents. It means there have some combinations of words. It's like that. So the definitions of the IDF, inverse document frequency, its definitions, it will be for a particular word wi in the whole data corpus. Suppose let's see data corpus, we have denoted it by DC simply. Data corpus. Okay. Here for we in ITF in term frequency we have find the word term frequency for a word for a particular sentences. But IDF we will find the for a particular word in whole documents. That's the main differences here. Okay, first difference it is. And its formula will be log of capital N divided by small n. That's what is this? What is this? This capital N means for the number of documents. We have seen this is the number of documents. And this ni, small ni, this ni is responsible for number of documents which contains this word. Number of documents which contains the word wi. That's the meaning. That's the thing. Okay. Now in the next video we will see why we have used the log for log term here to IDF. We'll see it in next video, but late. This is the formula actually of the IDF, inverse document frequency. This is the formula. Okay. So now let's try to count it somehow. Suppose let try to understand it. Suppose for R1 there have some word W1. There have in R2 R3 layer there have some R1 like that. Suppose let's some here RJ, here some word W1 like that, or here there have no W1, there have no W1, and there have no W1. Let So the IDF value for this IDF for this particular word W1 for the whole data set DC, its value, how much time W1 occur, how much time W1 occur. So in log first will be log. Total n means what? N means here how much, capital N, and how much time it's occur? 3 times, only 3 times. So let if n is equals to 1000, if n is equals to 1000, then this value will be log of 10,000 by 3. Okay, now there have, if you see it, there must be greater than 1. So here have must be beautiful property there have for this formula. So let's see what is this actually beautiful formula. So what we have learned, IDF, formula of IDF is for a particular word WI and the whole corpus DC, its formula is log of n by ni. We have seen it. So this is the formula, we have seen it. Now the thing is that the small ni it must be less than is equals to capital Ni. Means what? Here just see it. Small ni means what? Small ni means the documents which contains number of documents which contains this particular word WI. This means what? The number of documents which contains the particular word WI. Okay, and this capital N means what? This capital N means the number of documents that we have. So there have no possible that this small ni must be crossed this capital Ni. So this small ni always is less than capital N. So because of these reasons, we can conclude that capital N by small ni must be greater than is equals to 1. It must be greater than is equals to 1. That means what? That implies that log of capital N by small ni must be greater than is equals to 0. Must be greater than is equals to 0. So since we have seen, since we know log of 1 is what? 0, and it's greater than is equals to 1. That first reasons it must be greater than is equals to 0. I think you will understand it. Now another property also, they have some property. They also, if suppose let if we increase, we got somewhat, suppose let example, it will better if we take the let, and let the word we have considered the is the most frequent word, the, a, and, each, and like this kind of words is the most frequent word. If you see it, since it occur in every sentences or every documents, we will see this kind of if these things are happen, if WI is look like this type, if WI is if our WI is look like this, so if the WI is look like this, that means what? That means number of occurrences for this particular words are increased. So that means Ni is increased. So if Ni is increased, that means capital N by small ni must be decreased. Capital N is must always constant. So in our data sets, capital N is always constant. In our data set, capital N equals to constant value. It is the number of data point, means number of documents is in our data corpus. It's always constant. So N is always constant. So if Ni is decreased, that's actually the very So if ni is increased, then this value must be decreased. And always we know, that log is a monotonic functions. Okay, since log is a monotonic functions, then this value capital N by N I must be decreased. Hence, log is a monotonic functions. I think you will got, all of you got the idea of monotonic functions. In previous lectures I also discussed what is monotonic increasing functions, what is monotonic strictly increasing functions, what is monotonic decreasing functions. We already seen this concept. Okay, so log, since log is a monotonic function, so because of this reasons, this value log of n by small ni value must be decreased. Okay, so that means if you think these things literally in English, if you think these things in English language, so this means what? If some word wi is more frequent, in my data corpus, then the inverse document frequency is decreased. That means that's the actual internal meaning. So if more frequent means what? If suppose more frequent words means I'm talking about the a and each like of words. Okay, so if this wi, if this kind of wi got, so in such situations the idea value is decreased. So just think now. So in TF means term frequency will helps us by the word means actually it's wi. It is actually at the end of the day we have to calculate it. We have to calculate this vector. Suppose let's say review J. At the end of the day we have to calculate this vector and the h cell here, and here h cell of this vector. H cell must be content the value of TF and IDF value. So now TF will helps us by simple, it helps us for how much frequent the word we have. Means actually if you can think these things like a weightage value, you can think these things like a weightage value. This for this value actually how much weight we have to give him for each word. Okay, that means these things are actually how much weight. You can think like this thing, like this, how much weight we are given for a particular word. That's the actual internal meaning of this vector. That's the actual TA of IDF or actually internally doing this job. So the IDF as helps us how give the importance. You can think these things. The TF term frequency gives the importance of that word that's are more often occurs in a particular, in a single document, in a particular document. So we will give that more importance of that word. Those words are repeatedly occur in a particular documents. Okay, that's the actual internal meaning of this things. TF that gives us. And like think the IDF. What are doing? In IDF that's giving the WI is more frequented. Then if WI is more frequent in our whole data corpus, then we give the less important. Means here if you think this thing, that's just like that, the a and it's the more frequent word. Okay, it's the more frequent word in the whole data set. So in such situations, since the a and is not a more important word, so it's not carry some kind of important informations of particular sentences, So we have not given so much importance of that these kind of words. That's the actually job doing of the IDF. Means IDF, if give less importance of that word, that's the repeatedly occurs in our whole document. That the things are actually work with IDF. So TF are helps us by giving the more importance of that word that's repeatedly occurred in a single document, and IDF internally helps us by given the less importance of that word that's the repeatedly occurs in a whole document. Okay, so just write this thing that concludes. So TF helps us by given the weightage more repeated more repeated words in a single TF gives the more important. It really it gives the important of that word that's more repeated words in a single document. And now oppositically IDF means inverse job are doing the inverse job they have doing. That's the meaning of this. IDFs are helps us less importance. It gives the less importance here repeat. It is the less important of the repeated words in the whole document. In the whole document. That's the actually internal doing this kind of. So the IDF that we have seen here, the IDF that we have seen, the IDF is this. This IDF helps us. Those WIs is more frequent. It gives us the IDF gives us the less importance, means IDF value will be low. WI those who are more frequent in data corpus DC, and WI is a rare word. Is a rare word in our whole data sets DC. Then IDF gives us the more important. That's the actual internal meaning of it. Okay, I think you will got the point what I am want to tell you. So the thing that TF and IDF for the particular cell, the thing that we have doing, this TF IDF are doing this job because we have calculated TF for a particular word for a particular sentences RJ into IDF. We will calculate this IDF value like this for a particular word for a whole document on the whole document. This is the inverse. Inverse means if WI is occurs, then this value is decreased. If WI is occurs here, WI is occurs frequently, its value is increased. That's the. So in next video we'll see why we'll taken here the log term. We'll see this thing. So difference from this TF IDF and the back of words that we have already learned in previous videos. In back of word we have see these cells gives us the number of occurrences of a W in a particular sentences. So back of word gives us the number of occurrences of wi in rj. That's the w backup or are doing internally. But here tf-idf will giving us will gives us importance, means actually it is a probabilistic approach. Okay, we will give the importance of those words that are more frequent in a single text, means in a single documents, and it's rare frequent in the whole document. That's the actually tf-idf. Yeah, tf-idf gives us will give the importance of those words, will give the importance of those who are wi occurs more frequent in a particular occurs frequent in a particular documents, and plus the words which rare frequent, means which rare in full documents. These kind of words they have given the more important. Okay, that's the actual main differences. I think you will now I got the idea how these things are actually work. So if you conclude this, lectures, we got from this tf-idf a concept, that we got from this tf-idf. This tf-idf will help us, this tf IDF will helps us by giving the more importance to the word in my data corpus, and give the more importance if the words is more frequent in the whole sentences in a single document. Okay, it gives this IDF more importance to the rare words in the whole document, and it's give the more importance, and it give the importance of that word more or that word if a word is frequent in a particular document, or you can call it a particular review. These are the job that are actually internally doing by this tf-idf. Okay, but there have also problem on this tf-idf. So let's see what is the problem, what is the drawback of this algorithm. What are the now let's see what are the drawbacks of it. What are those drawbacks that still now we have to test on this? So the drawback is semantic meaning. It's just previous video, if you remember, we have find two type of text, tasty and delicious. So these are the actually internal meaning are the same, tasty and delicious, and you can see the cheap or affordable, both are the same words, but tf-idf till now it is not can treat these are the same type of word. It's taken as a different word. It's taken both are the same word, internal meaning is same, but if IDF it cannot solve this issue. Okay, means it's semantically the semantically same cement, you can call these things as semantically semantic meaning, the same kind of semantic meaning word, those are the semantically same words, they cannot find, those are the semantically same words. Okay, these are the main drawbacks of it. So we will solve it as well. We have improved some theorem what to bake in, we'll see as time progresses, we will see this thing how we'll solve this issue. But the main drawback it's here, but it cannot handle this type of problem. So but main advantage is this. So those are simple backup words that we have learned. The problem that we have faced in backup words, that things can easily be handled by this TF-IDF technique. Okay, I think you will got the details, understands what is the importance of this term frequency and what is the importance of the inverse term frequency. You will, if you think these two terms internally, then you can got its answer. Term frequency means we have give the importance of that word, those are the more frequent in a particular document. Inverse document frequency, inverse means, first inverse means you got the idea, inverse means some gives the opposite kind of thing. Document means if you consider whole documents, frequency means we will give the importance of that words that are the rare in our whole document. Is for means more we will give the less importance of the word that's are the more frequent in the whole document, that is like the, a, and like that of words we have given the less importance, and we will give the rare, like you can rare word, you can see every document there have a rare word. Okay, in the whole document corpuses, if there are some words as a more rare word, we will give the more importance of the particular. Okay, that's the main importance of the TF-IDF. Now we will, next video we will see why we will use the lock term in the TF-IDF. We will see it why we have used this lock. You can easily, it can be, anyone can be asked, why sir I have used, if it is inverse, then why I am not using the n by simple n by small ni? It's also inverse formula, but why I am using this lock? So we'll see these things why actually I have used this lock.